So now I've done a bit of an introduction about BIM. This was a lot focused on high-rise buildings. So as you know, that high-rise buildings are a bit easier in that way, but they still need to touch the ground. They still need to be on the ground, and that's the area that we are dealing with. So we need to first create that foundation, and then when foundation is in place and well established, then the whole building information modeling goes really fast. And you see that with some of the beautiful examples you have here in the city as well, and your neighboring countries, they're using this type of models already. So it's a lot of this, what we see today. So it's basically BIM wash, it's called. So information that it's actually a term that's been used, and it's in part of Wikipedia already, is called BIM wash or BIM washing. It's a term describing the inflated and deceptive claims of using or delivering BIM services or products. It's becoming quite ridiculous what individual consultants are offering you, and it's becoming a bit of a confusion. So when you are basically unintentional BIM wash, it's almost like a confusion. When you're dealing with inexperience, so basically the low level of BIM wash, when we're dealing with the mid-level of BIM wash, it's basically exaggeration, so that I'm selling a lot of non-right things. And then the highest, basically, it's the illusion. So something that a consultant sells to the client saying, we're going to do everything in BIM and everything is in place. So it's a bit of an illusion. We're still going there, and this is still quite a far way to go. But we want to know that sometimes you will hear a lot of things about BIM. It's not there yet, but it's going really fast. So why do we use BIM? What are the real benefits of BIM? We are going into the area of automatization of big data. We are really dealing with a lot of data, and I'm 100% sure that my colleague over there, when he will start about tunnel boring machines, there is a lot of data. Every time that wheel turns, we generate millions of points over the whole parameter of a tunnel. So we're dealing with large data, and we're really looking at that our domain of civil engineering is really changing, and it's becoming very attractive to the various fields of engineering. So we see in the increase of the student intake at our universities that the civil engineering discipline is really becoming an attractive tool, and it's basically adding the value towards the industry. So what do we want to do with BIM? Why are we developing these BIM things? Because we want to really put our past experience, and we are very confident with the past experience, how we've been building tunnels for many years, and we want to integrate that experience, and we want to prepare the standards for the future. So we want to make our lives easier, because the construction and the projects that we're going into with years to come, they are becoming more difficult. Why should we have our difficulties with designing the things if we know that we've been doing the design very well for the past years? So one thing, if you remember out of my lecture today, that BIM for high-rise buildings is not a fall-down tower and a bit of a squid. That's something that I would like you to remember today, and if you take this message home and explain to your peers that and if someone wants to sell you BIM for high-rise buildings, you need to tell them that you've seen this slide and it's not true, okay? And we all know, because we're tunneling engineers. So what are those things that are most important things when we're doing BIM for underground infrastructure? First and foremost important thing is our geology and our geotechnics. We need to understand that. We need to implement that component into our BIM. If we don't have that, it's no point in going forward. So it's really important that we know our geology. The second thing is, we're going to make that hole into that ground. How are we going to do our temporary works? How we are actually making a hole in the ground. What is a lot of time an illusion is when we have these high-rise buildings that they're just standing there in the mid-air. No, we are dealing with geology, we're dealing with water, we're dealing with faults, so we want to know what our temporary works is, how we actually, that ground is going to stand. So here we're bringing our fundamentals, how stress is distributed amongst the lining, how the support is happening. All of this is coming in place. Then we are putting all of that into our GIS. So we have various, as you all know, we have various coordinate systems as part of our construction. So we need to implement that, and we need to talk in the same language. And then we have these permanent structures that you usually see in high-rise buildings, and that's the area that is quite well developed already, and it's basically really supporting that construction industry. So how are we doing all of that, and how are we staging this? We need to do parametrics. So for our designs to be feasible, we need to start using various types of parametric tools. We need to overlook at our geology, we need to look at population, topography, alignment, just for our alignment. And that's what we always do. But how can we integrate that into our beam model for our tunnels? And then we have our so-called segregated designs, where we basically have a detailed design of all of our components in a tunnel. So now we're going to go through various steps of this parametric strategy. So as you all know, we have cross-sections in tunnels, and we basically have these cross-sections changing throughout the chainage of our construction. And for example, here is just one model that it's actually parametrically built. This means that all of these parameters are continuously changing through the alignment of our structure. All of these parametric models or families, as they are called, have coordinate points. They are coordinated with all of our coordinate systems. And apologies, you can't see this, but I just wanted to showcase there is a table behind every parametric model. There is a table that directly outlines where this cross-section is. Then we look at our whole alignment, and we basically can create coordinates of these profiles to be created by themselves. So they move based on the predetermined scenarios, and we basically can populate our whole alignment. So we start creating blocks. So our alignment is slowly progressing, and we have series of these families that they're created into blocks, and they can be interconnected with each other. So we basically create our tunnel structures. In that medium, we have enlargement. So we can have not just that, we can enlarge our tunnel. Instead of having a two-lane traffic tunnel, as it was shown before, we have our parking bay niche adjacent to it. In addition to that, we need to look at our interventions, such as drainage things, utilities, various types of suppression systems, and basically as well how these interventions are interconnected. So even these interventions are interconnected. So if we do change and our client says that the parking bay niche is actually will not be here because we know that there is a few meters further a new ramp is going to come in, so we need to change this niche. So automatically when we change this niche, all of these interventions are interconnected. So parametrizations are very important that we are overlooking at. So we're really looking at how we are analyzing the alignment, how we are overlooking at the cost estimates, where are the risks that we are taking, and we're defining best excavation methods. So we're putting all of this into the same model, and as you can see over there, we are really observing our geology. So geology is coming into place, and we are modeling our geology as well. So there are various tools available that they're doing that, and we're basically putting all of these models together, and we're trying to see how they interconnect. So we start basically creating this analysis or multi-critical analysis that they give us our limit state designs for this. And we're trying to look at our analytical stability calculations. So we always come back to what governs that support. So it's very nice. We can create something like that. We basically put every rock bolt and every support system and every concrete shotcrete embedded inside. So we basically can put a very comprehensive model, and we can basically open it and showcase it to everyone. But this, it's not well distinguished between our support classes. So you can always see that we are going into that the level of information by the model is it's too detailed. So if I would give you this model, and it's a whole model, it's basically looking like a hedgehog around the alignment. So we want to make and visible that information that it's interesting to us as a tunneling engineers. Why do we need? We need to know what is that rock bolt, what is that sets of rock bolts that we're going to be using. We need to know what our steel arches are, which arches are needed at that time of the construction. So we can then really start investigating what type of information is needed for further analysis of that. The constructability, when are those arches going to be developed? Where are those arches going to be developed, and how they're going to be delivered to the constructions and to the face of the tunnel? So for us, tunneling engineers, we know what a rock bolt is, we know what a support is, so we can start defining areas of the support types. So we can completely abolish what you've seen on the top, because we know that. We are trying to showcase to the client that we have rock bolts and we have support, but all of you know that we have rock bolts and supports. So for us as designers of tunnels, this is what we need. We need enriched data on that profile. So we have the profiles that we have, but we basically can just add a specific color to that profile or a given family to the profile, and we then can proceed with further analysis. So once all of these models are established, we then can overlook at what can we do with them. So we basically create some type of block models, and some of you are very familiar with this environment. We can actually export that through our common data environment, and we can create some finite element analysis of this complex environment. So why wouldn't we use these models, 3D models that we just created? Why wouldn't we use them in our FEM models or DEM models, for example? And again, this has to be interactive and it has to behave one back and forward. So when we do an analysis, basically that export of the analysis should come back into our design. So as I mentioned before, we want to create that federated model. We want to invite everyone from various disciplines to come and to contribute towards that model. So if we look over here, we have various types of tools. Apologies for those tools that they are not on the board, from those of the suppliers that I know that they're in the room. But it doesn't matter actually what the name of that application is. These applications are going to change. The way this is done is changing so rapidly that we should not be concerned about that. We are concerned about how these are talking to each other. We want to know that when rock bolt supports are designed, that they're actually interconnected with our arch support design. So we want to know that they discuss to each other, that we know that they're actually constructible. So these are the areas that we need to look. So we need to look at various disciplines, upskill themselves, and use the standards of global standards, and that they can be used in this federated model. Only then we can start producing models that they're of use to us, to tunneling engineers. And only then we can start doing so-called clash detections that they make any sense, so that we know when a constructability is going to take place, that we will basically be able to construct it. So when we have a given segregation model like that, we know that from a client's perspective, it's just a concrete lining. But we know that within that concrete lining, there are various things in place, which no one knows except us that it's in that tunnel. So we have our road design. Based on that, we have our mechanical installations. We have our electrical installations. Of course, we have our dewatering. Everything is in the model, and it's interconnected. So we know that when we are constructing these models, that's in place. So we can, of course, switch off all these beautiful colors, and we just leave the concrete lining for client to see, or for an operator to be dealing with. So what do we need to do to have these models that they basically come in place and that they actually start developing? So we have so-called Employer's Information Requirement, or EIR. So this is very important that the client knows what they want. So if a client knows what they want, then they will not be asking for something that it's impossible to deliver. Because the clients talk to each other, and then a client of a high-rise building said, we had all these beautiful beam models, and then a client of a tunnel says, I would like to have a nice beam model as well, and it's impossible to deliver to that level of details that a high-rise building is doing at the moment. So we have various things that we need to discuss about, and these are basically our project goals, what type of software platforms are available in that country, what are the roles and responsibility of individual party that it's contributing towards. So we do so-called BIM execution plan. So we really want to know what, or BEP, is what our design team and contractor is going to bring to the table, and we want to know what our employer is asking for. So we really need to spend a lot of time on this so that we know that from a designer's point of view and a consultant's point of view, that we are basically producing material that the client wants and that we're getting paid for it. So that's what we want to know. So there's various execution plan guides already available online, and that's something that I would like you to go and have a look if you're dealing with a client, that you as a consultant or as a designer, you educate the client. The client will ask for everything, and you're going to have to deliver if they are not knowledgeable about the environment. So it's your role as a consultant and the designers to educate the client. So we are looking at various types of identification of goals. What does actually client wants? That has to be very clear, and it has to be well established in our planning process and when we're doing our development. And especially at the end, we want to know that the things that we've created, the models that we've done, the design that we've done, conventional and digital, that it's at the given handover that the client is satisfied. So it's all about these BIM, CC, and C. It's all about the communication, collaboration, and coordination. So if you can imagine that poor person over there in the middle of the room, if they make a mistake, everyone will see it. Everyone will hear it, and that person will not be happy about it. So we have all these standards that we need to play with, and we are really trying to engage that environment to an extent that we can. And the guidelines specific that we were discussing about before, they already exist. And we're talking from British standards with German standards, then we have some European standards as well. But this is just something that it's continuously developed, and this is something that we should be implementing. We all know that as tunnel designers, there is no such thing as one standard for tunneling. We as tunnelers, we need to continuously overview various standards from our materials to our constructability to our support systems, and we need to adjust based on our geology. So as well, all of these standards are good, but if they are not suited for your project, you need to find the best standard for that project. So when we start our BIM and our BIM execution, our goal is very simple. We basically, we know what we're going into, and we know where is the end. We know where the finish of that project is, and we know that it's a beautiful line. Reality is a bit different. Reality is that we have to go through various hurdles, and environments that we don't want to go through and that we really want to breach in the nicest way possible. So if we put that into our BEAM ideology, is that we are that gentleman over there coming with a bicycle to the employer, and we ask the employer, what would you like? And the employer says, everything. And put it in that box and deliver it me. So then it takes us a few months to collaborate with the employer, with the client, and discuss what actually is that building execution plan. What is the important for your project to reach the goal? What are those things that you need? And then, of course, we're going to have some various workshops in that, because we really want to get this triangle. We really want to get the process right, we want to collaborate with the people, and we want to use the best technology available for that project that we're delivering. So the process, people, and technology, this is something that we've been doing for as many years as the project have been doing. But the problem is that the larger the projects are becoming, the harder it is to communicate amongst parties, and the more bodies are involved. So it's really important that we keep this triangle close together, because we are the ones who are constructing this project, not someone else. So we have our BEAM, 3D BEAM model, but we still need to bridge that water, because everyone on the table is going to come and bring their own model. So how do these models actually work together? So we really want to know that we want to merge them all together, and we actually want to see if they work. And maybe if you're going to put all the models together, initially they're going to work 40% together, and then with iteration of quality control, you will come to that sensible number that we're going to. You will never reach 100%. Please don't aim for 100%, because no other construction is aiming for 100%, and we definitely in tunneling are not aiming for 100% constructability. So when we look at this, only then we can then start investigating how our clashes are actually interacting and our constructabilities. So now we are here. We are in this 3D BEAM environment. We've created our models, but we need to get to that constructability, and we need to get to those costs. So that 5D BEAM over there, which is actually covering the costs. So we have these beautiful tunnels, and we just know by fundamentals, we know that the C25-30 or C35/45, if you know about materials, you know that if you're ordering materials and if you make a mistake like that, it's a significant mistake. So we need to know that when we are defining our classes, that we use a specific terminology. What does it mean if we use specific words? So when we're actually looking at our 3D models, and when we are looking at how to, what is requirement? What is the estimated time requirement to create a BEAM model? We see that we actually, when we are in 3D modeling, and if we want to enrich that model with a BEAM coordination to get to the constructability, it's a very small effort. But to get to that cost estimate, it's a significant requirement in our modeling, how to proceed with that. So there are various solutions: standardization and integration. So for a given project, high-rise project, for example, we create our standard database. We have our elements, which have their own classifications. They have their own properties. They have standard names and values. And we basically know for who, for what, and when they need to be delivered on site. So we know, we talk to the client, we basically have our requirements, and then we have various tools that these elements can be constructed with. We place them into the common data environment, and we know that they discuss to each other. When we're dealing with underground construction, we basically don't have a standardization yet. There is no IFC tunnel as we speak. So we need to overlook at the software that we're using. We need to see how they collaborate. So we we need to introduce a quality control software. We need to have tools that they're overlooking at various tools so that we know that if the company that is dealing with constructability things of mechanical and electrical solutions is actually their models are working with our models that we're doing with the support system so that we know that those bolts that they're going to go through will not cut through the water membrane at a given location. So we want to know where those M&Es are going to be actually located before we start with the construction. We create these databases that we then can actually communicate and discuss to the client. So now that we're going into utilizing the BIM into the environment, and when we're looking at basically what can we do with this information, we look at from our construction data, we're looking from our monitoring data, and we're looking from our design data. It all feeds the model. But what do we want to actually do with this information? And that's where the beauty starts. We have large data sets, but we want to know what the client wants to see, what the contractor wants to see, what a supplier wants to see, and what various types of individuals that they are contributed to that project. Community, what does the community want to see? Community wants to see a beautiful visualization of a project, and they want to see how they're going to be using this tunnel when it is constructed. Basically, the supplier wants to know when they need to provide the bolts, and so on, and when does everything needs to be in place. I will go through these elements in a bit more detail, and when basically we want to define the goals. We want to be well-defined, we want to have well-defined rules, and we want to have a nice workflow through our construction. So when we're looking at these collaborative protocols, the key thing is our quality. So with all these models, we are improving the quality, we are improving the design, and we are not taking any fundamental knowledge away. We are improving that, we are enhancing it. And we are basically modeling on a specific guidelines. So when we're looking at the project goals, when we look at our data analysis and our geometrical design, we're looking at our cost estimations, our time schedule estimates, resource management and planning, real data analysis and scenario analysis repeatedly. So we basically want to know how do we create our production model. This is the model that I was showing you before about our support systems, where our niches come in place, where our interventions come in place. So us as a constructors, we want to know where does a given support come in. So we want to know that each design description has own software where design is performed. So we want to really bring forward that software that it's best for support systems, that it's best for ground modeling, that it's best for waterproofing systems. And we want to create that each of these software can be exported into a common data environment so that it actually contributes towards our federated model, and that it's a slow and complex process to reach a suitable quality, but it's the most important thing that we contribute towards our federated model. So when we're looking at the federated model over there, we saw that we basically really want to focus on the design accuracy. We want to focus on the clash elimination. So we want to look at that quality assurance. We want to look how this C&C discussion, so basically how we are collaboratively working in this environment, and we want to start creating a bill of quantities. We want to really look at that time scheduling of the project. So we want to start using parametric tools that they are less detailed but more automized. We want to use the repeatability. So with repeatability, we can actually increase the designs. We want to be well-organized data, and we actually want to organize the data as well. And we want to analyze various types of large tool sets. So if you know these gentlemen over there, we basically need to use available software tools on online, which are sadly not available as we speak. So we need to improvise, adopt, and overcome. So when we look at these BIM technologies and challenges that we are facing as we speak, is we want to know what the interoperability is, what the performance is, specialized tools for tunnelings, and multi-scale modeling. So we really want to know what these technology challenges are as we speak at the moment. We want to know what the modeling challenges are. What are these model divisions that we are, what are these large data sets that we need to model, and how are those parametric properties and data sets actually working with our parametric models. And only then we can start focusing about the dimensions, about cost and time to do that. To achieve all of that, we need to overlook at our management. We really need to know who's managing that data, who's managing these models, and how is that information disseminated. There is a term that we see over there, which is called closed beam or open beam environment. Closed beam means that you're using a given tool and that you're only using that tool and your tool is not compatible with other tools for on other construction sites or something like that. So the drive is towards open beam environment. So we really want to have all these tools that I've showed you so far, we want them to be basically working with each other. So our parametric models. So in the background, we have this interesting structure, tree structure behind it, but we are getting what we want to get, what us as our tunnel designers we want. We want to know what our cross-section is. We want to know what our support system is. We want to know how the support is basically got to be outlined, and we want to know how we should cut it. And this. So it's all coming back, but in the background, we're dealing with lots of metadata and large data that it's continuously overlooking at each individual parameters of that tunnel construction. We have our tunnel cross-section. We have various types of support types with the different geometries that we know. And basically, that's how it looks like in a software. So it's all of these points that you see over there. They are collaborative and working together. So if you look at this model over here, it's basically, it's changing as we speak as we continue with the chainage. If we change the chainage over here, we always need to know that fundamental and basics of a tunnel lining are correct at every given point. So we need to know that our compressive stresses are there, that basically, that if we cannot have concrete in tension and all of these. So all of these environments are actually embedded in these models. So what are these challenges? We basically project submission and beam models submission is on the same day. So sometimes a client will change something and say, can you change this by tomorrow? We can, because we have parametric models. So we can adjust that construction by doing that. Tunnel support design is not finished until a week before the submission. So this is based on the various procurement methods that we have at the moment and the processes that we go into design and contract that the client wants to know when is that support design going to be finished, and we only have a period of a week to do that submission. Changes of tunnel components during the design stage, that the models are continuously changing based on the constructability processes, and client wants to make some changes and have results the very next day. So this is something that we really trying to bring the client, the operator, the constructor behind the same table, and if there are many of them behind the same common data environment, that we can communicate amongst each other. And what we're doing, we start doing what we were doing in the beginning, before any of these things was available. We're basically exploring different design options. What we as an engineer should be doing, we should be exploring what a best design is for our construction. We should not be focusing of this large metadata and everything behind. We should be focusing about delivering the best design to our client. So We have a beautiful snake underground, and we are shifting alignment, and we want to change that alignment. We want to change that cavern. We want to change that ramp into our design. So we want to shift the alignment. So what are the consequences of that? We are basically changing the spreadsheets. We rerun the routine for generating the models. So we basically overlook at all the cross sections. We look at all the niches interventions, and then we basically return to analysis. So it's a big step that you do by changing the alignment, but it's not impossible. There are just specific steps that you have to do. When you're changing the cross-section, means that you're changing the parameters that govern the information of cross-section. So we are now changing this. We maybe change the concrete design. We maybe change the things that we've designed in niches at a specific length, maybe suppression. We change the tunnel suppression, fire suppression systems, and that generates a rerun of the whole model. And we, again, rerun the analysis. So one thing I haven't discussed about that much today is geology. Geology is very unpredictable. So, and we know that as tunnel engineers, we always focus on, and we're improving our models based on the geology. We have various types of ground types because of geology. Otherwise, we would have one ground type and we would go forward. In this case, no. We almost have to adopt the models. We need to review what is the current data that a geologist brought forward. We want to work in the same environment. We want that our geologists and our stakeholders are discussing with us, and we're basically looking at how is this going to intervene in our short-term model, how is this going to intervene in our long-term model, and so forth. We want to create an experiment model, and we want to put forward our hypotheses and test them with those inputs before the construction. We want to really try to use the data that we have available and try our support systems. Do FEM analysis, do DEM analysis based on that parameterization that we're doing, so that we actually see when we are going in advancement that does that actually work together? Is there a point into doing that? There is lots of these steps that they are introduced with metadata that I've showed, but now I'm going to focus just a little bit more about constructability. So we're doing our logistics. We know we have a large tunnel construction in rock conditions, and we are using, in this case, we're using road headers. So we're using 2 road headers, or 2 basically advances. We know exactly what our cutting of the first tunnel boring machine is, how long is it cutting, how long does it take to place a bolt inside, how long does it take to place shotcrete inside. In extended, we know what the efficiency of individual machine is. We know that our contractor knows all of that information. So we then know how long does it take to do the top heading, how long does it take to do the bench, and basically cumulative, what is the advance rate of the top heading and invert per day. So we can actually stage our construction really well. When we have all of that, we can basically computer assign paths of a road header based on the predefined rules. And we will see that today already, that suppliers of machine delivery, basically they know that these models are well in place, and we know that they can work together in the support system, so we know where a given machine needs to stand for a given staging. So when we know all of this, then we can start dealing with our 4D, so we can start dealing with time. So we actually know how our advancement is going to happen. In this case, we're looking at the large opening of a tunnel with a road header. We have, on top, we have 2 road headers and a pillar in between. And on the left tunnel over there, we basically just had 2 road headers simultaneously. 1 road header basically excavating both sides, while the other one has 2 road headers. So we want to really know how our parametric model can be optimized. Every contractor is going to say, yeah, that's fine, you have these beautiful models, how can I get my money? This model is going to cost some money to build, how I can get my money back by you introducing me this technology. Optimization. That's where basically we're looking at. We're trying to use this data, we're trying to create a common language that this data can be used and it's useful for the contractor. So when we can actually introduce specific quantities to the contractor, then a contractor see the value is building these models, and they will be looking at how this changing actually affects on their construction and constructability. So we look at the given tunnel in Sydney. There is a large tunnel being constructed as we speak. It's in the order of 36 kilometers. At the peak of this construction, there will be around, if I'm not mistaken, 64 road headers being constructed. It's in Hawkesbury sandstone, which is ideal rock ground conditions for open face excavation. But for a given project, we see that we're getting a large tunnels coming from the south, we're getting large tunnels coming from the east, and we're getting tunnels from the west and coming from the east. So we're overlooking at a large intersection. So what we're dealing with 18 tunnels that they will have to be built simultaneously. We're looking at 65 cross passages. And now we're going into these things, metadata. So we're looking at how many things we need to think through to actually construct a tunnel like this. And just by developing what I've showed you before, we're looking in 10 million different types of attributes. We're looking at 100,000 plus activities that they're simulated and interworking. All of this, it's becoming very complicated because we're dealing with dependencies. We know that the tunneling industry is different to mining industry. Mining has various phase advances. We have one phase, we have one advance. In this case, we have 18 advances, so we really need to know dependencies. Where does that still need to come on that hour? So when we look at a project like this, we can actually model it. So I will run this video twice so you actually understand what's the whole thing behind it. So as you can see, the colors are changing, and basically it's showing the constructability of that. You want to actually showcase to the contractor how you're going to build your tunnel. How is a designer envisaging that tunnel to be built? Focusing on geology, focusing on water, focusing on all the facilities up that they are there. And we know that everything that we designed on, we can give it to the contractor and say, you can build this tunnel because we as designers are confident that this will be able to basically go with this process. So I'll go back and I will play it again. But what does actually a contractor want to know? They want to know how much rock they're going to excavate. And we're talking here in cubical meters or tons. We want to know how much shotcrete they're going to use at a given time. So how much concrete needs to be delivered. They want to know how many rock bolts they need to put, and these numbers are going into 150,000 plus. And we want to know what are those utilities that have to be installed and planned in advance when this tunnel is being excavated. So as you can see, almost everything is excavated. We came to 26 million cubic tons of material. We see that we finished with shotcrete. We don't use the rock bolts. But really, these M&Es are really increasing. So we really want to know that fitting of the tunnel. And it's going to look like the final version of the tunnel. So we have first model was done in about 5 weeks. And then at least 20 model scenarios were done during the following 3 months. So you really see that those, after when the model was finished, the discussion between the contractor, the client, really took place, and various models, scenarios were being built. The client really wanted to understand how this complex tunnel is going to be built. Various standards and guidelines were used for that. But as well, there was a lot of thought about the maintenance, how these tunnels are actually going to be used and operated. So that's something that we know now that we can construct it, but do we actually know if it's going to be working and how it's going to be working? And that's something that is becoming very difficult to understand, how these large tunnels are going to be used by us later on when we drive through. So various types of things that we're going to go through later on. But I wanted to just tell you two more things. One is that we have, on the international platform, ITA has various working groups. And we've created a few years ago a working group 22, which is dealing in information modeling in tunneling. And this group is growing quite a lot. So I do wish that you would contribute towards these working groups, because that's where all this information gets disseminated, and then we're asking you, member nation participants, to bring that to your member nation country. We have various objectives of these working groups, and we are not just working with standardization body. We are working with the mining group as well. Mining society is much more advanced than the tunneling society is. They know when they will take that ore out of the ground before they even start excavating. They know their cost-benefit analysis better than anyone else. So we are working very close with the mining sector, and we're focusing on geology, how they're interpreting geology and the support systems. As I mentioned before, there are use case management platforms available for you. You, as a member nation, have access to this. And I would encourage you to go there and see what these use case scenarios are. And to finish, we need to start creating flexible designs. We need to focus on our fast change in management. We know that there are differences coming up. We want to know that the instant quantities that we are producing are of use. For what? So that we can then work in an environment, common data environment, and that we can collaborate as we used to. But the projects are becoming more difficult, so we need to use these common data environments because we need help. And if that help is through automation, if that help is through 3D visualization, everything is helping if it helps us to build a project like that. What we want to know, that our quality control has less errors, and we design better with our cost, with our time, and further on. So thank you very much.